So I'm Surya. I'm one of the co-founders at Skill-Lync, and Sarang is another co-founder. So Sarang and I started Skill-Lync 4 years back, and the goal was to provide more industry-relevant coursework to students in order to help them get the skills that will help them get jobs. Right. Um, so that's what we have been doing over the last 3 to 4 years, and we have had huge success. So right now we are almost touching 500 students placed over the last two years, especially in core engineering domains, and we have some of the most niche courses for mechanical, electrical, and automotive engineers in order to help them get succeed as well. So folks, if you have not seen our website, just to give you a quick overview of what we do. So this is our website. I'm just going to share my screen and show you. Sarang, can you see my screen?
Yeah, Surya.
Okay, great. So skilling.com is our website, and we basically provide, as I said, job leading courses that focus on having industry relevant skills. What students at Skill-Lync do is work on multi projects. So as I said, we work on mechanical, electrical, civil, and computer science. In mechanical, we have a whole spread of courses like computational fluid dynamics, coursework, computer aided engineering, structural analysis, hybrid electric vehicle design, and design engineers masters. These are a few of the courses. We have new courses on automotive, autonomous vehicles, computer vision, computer motion control, trajectory optimization, and so on. Right? Just if you are not aware of Skilling, I just wanted to give you a quick overview of that. Right? So I'm going to stop my share and kind of start with a few questions, right? One of the since a lot of students are here, so I have one of the questions that hear a lot is what are the skill sets that how is the job scenario right now in the industry, right? With COVID and everything, a lot of people ask us this question: what is the scenario with respect to jobs for core mechanical engineering domain in the industry right now? Right. So when the COVID first wave hit, there was some sort of uncertainty, but right now there is a lot more clarity with automotive and especially engineering services companies with respect to the hiring process. So there are a lot of requirements, especially in automotive, oil and gas, power, heavy manufacturing industries, right? There are a lot of opportunities that are available and that are coming up, especially in the design and development stage. So when I say in the design and development stage, what do I mean? Design is product design and manufacturing design. Development usually is analysis with respect to computer-aided engineering, which subdivides into finite element analysis, computational fluid dynamics, multi-body dynamics. Some bit of electric vehicle design and development is also kind of coming up right now in the industry, by understanding battery management systems, understanding a lot about other aspects such as motors, DC-DC motors, controllers, and so on is kind of coming up as well. So that being said, there are a lot of opportunities, and especially in the 0 to 4 year category, there are a lot of opportunities. Right, one of the most common thing is freshers do not get a job because of lack of experience. We have found out that there is a way around it, and would love to kind of speak about that as well. So let me kind of start taking questions. So if you have a particular question that you would like to start with, I can basically start taking questions through your chat box. So please please type your questions in the chat box, and we can basically start answering those questions. Right? As the questions kind of come up, what I can essentially do is one of the questions that people had for Sarang was, I'm a mechanical engineer, and in my fourth and final year, and I'm interested in electric vehicles. As a mechanical engineer moving into electric vehicles, will electrical engineers be the only people who get an opportunity in electric vehicles, or can a mechanical engineer also have an opportunity in the electric vehicle industry? If so, what are the opportunities available?
Great. Thank you, Surya. So, guys, first of all, I hope I'm audible. My name is Sarang, and essentially, I would like to answer this question in a very by giving some examples. See, if you look at an electric vehicle, and if you essentially look at the components that it's made up of, instead of your IC engine, a pure electric vehicle is going to have a traction motor, and then it's going to have a larger battery pack, and then you will have onboard power converters, which is essentially used to provide the voltage at the required level for whatever component it's delivering to. And then pretty much every other mechanical engineering systems, like your suspension and any of the structural components, don't change a whole lot, right? So if you essentially want to work for a company that does that creates or that manufactures electric vehicles, then from an opportunity point of view, yes, mechanical engineers can definitely expect opportunities. But the key thing to note is the system is essentially getting more improvements and more updates, primarily on the electric side, on the software side. If I want to give a simple example, think about your typical suspension systems, right? Suspension systems over the last 10 years, if you look at the amount of development that has taken place, right? Obviously, there were several new technologies that were introduced, but then over the recent years, majority of the technologies are either software based or hardware based, which where the hardware is essentially made up of electronic equipment. So the idea is essentially the car is getting more electrified, not only in terms of just having a larger motor and a smaller engine. You're also getting more software and more hardware, and hardware, when I say purely electrical and electronics, getting added into the automotive, right? And this is a trend that would essentially continue across any type of transportation system. So as this happens, obviously the role of a mechanical engineer slightly modifies. If you look at a mechanical engineer, traditionally, they would have from a skill set point of view, right, they would have very good fundamentals in engineering. So essentially, if you look at the electric vehicle as a system, the engineer will be able to describe what the system does, and you will be able to do fundamental stuff like energy flow analysis, understand what are the key efficiency bottlenecks within the vehicle. But then beyond that, when the mechanical engineer has to look into the system, right? For example, if you have to understand how a battery pack has to be cooled, you need to essentially understand what is the heat load that is typically obtained from a battery pack. So when we say heat load, what I mean is, how many watts of power does your battery pack emit, right, at a given operating load. In order for you to understand that, suddenly you have to have a much finer understanding of the battery pack, right? So essentially, short answer is yes, mechanical engineers can expect jobs, but the key thing to note is mechanical engineers now have to wear slightly different hats, and your skills need to be a bit more cross disciplinary, which means you can't just be looking at your good old thermal systems, fluid mechanics, design, and manufacturing. You suddenly need a little bit of knowledge in basics of electrical, electronics, and definitely a reasonable amount of digital skills, which would be computer programming, data analysis, data handling, and so on.
Great, Sarah. Thank you so much. I think the next question was with respect to a couple of them asked this question. I am experienced in production and quality, right? I am in the manufacturing side of the sector in a core company. Now I have like 0 to 4 years of experience in that particular domain. I want to get to the design and development or the CAE field. How should I? Is that possible? Number one. How should I go about that? Is number two.
See, the short answer is yes, and I think this is one of the things over the last 10 to 12 months we have seen and helped a lot of students. So essentially, if you look at a production engineer or a manufacturing engineer, depending on the companies that you work for, your work might be very, very, I would say, more towards the managerial side and less towards the technical side. Though the first 2 to 3 months of job is very exciting because you get to know things at a with good range, meaning you understand what happens, but you definitely lack the depth. And typically, if you're working in as a production engineer or a manufacturing engineer, if it's a reasonably established company, there's not a lot of room for you to essentially innovate in your job, right? So in the past, we've had a lot of people essentially making the same career change. And yes, short answer is it's very easy to get a job. And typically, what we have seen is we have seen huge success in students essentially coming to a design program where, since you have worked in production or quality, working on design suddenly become you're essentially broadening your skill sets. And with respect to design, there is broadly two domains, right? Plastics and sheet metals. But then depending on the vertical that you're working for, it could be automotive, it could be rail domain, or it could be aviation. Depending upon the domain that you wish to work for, you need to essentially put yourself through a comprehensive set of program where you work on a lot of projects. And essentially you can definitely expect a career change, say somewhere in 6 to 8 months time frame for sure. And the verticals to go for at this point would be automotive, oil and gas, and also rail. When I say rail, I'm talking about rail body design.
Great. I also wanted to chip into a little bit of that particular question with respect to. Oh, I wanted to add what Sarang said, right? So, if you are in production and quality, you already have an advantage. We have been speaking to a lot of industries right now, right? One of the things that they basically say is, say, when they are looking for a 2 years experienced person, they look for, say, I'm going to take up a design example, and when they look for a design candidate, they do not look for 2 years of design experience. Even if they have 2 years of manufacturing or quality experience, it is additional. In addition to that, they need to be very, very good at understanding the engineering fundamentals and applying the engineering fundamentals using a particular design tool. It can be CATIA, NXCAD, Creo, AutoCAD, whatnot. Essentially, they want individuals who have worked on design problems, right? With a manufacturing or a quality experience, that's always additional, right? One of the things that we have out of experience. So, as I said in the beginning, placing 500 students, what one thing that we have understood very well is what does industry expect, right? When industry expects work experience, they are speaking about engineering experience. That's very important to understand. What is engineering experience? Even if you do not have if you are working in production or quality, or even if you're a fresher, right? Even if you do not have that work experience where you are not working at a Tata Motors or a HCL Technologies, you can gain that experience, right? There are platforms which will allow you to gain that experience by working on certain projects, right? I'm going to quickly share my screen and show you a few things on how you can get those experiences, right? Say, for example, Sarang, can you see my screen?
Yeah, Surya, I
See,
can.
for example, out here, you're basically seeing Praveen Kumar's profile, right? I can also put it in the chat box for you guys. So, Praveen Kumar's profile, what you basically are seeing out here is essentially he's a student at Skill-Lync. He's a student in the Masters in Hybrid Electric Vehicle program. So these are the projects that Praveen Kumar has worked on. When an industry hires or interviews, or whenever they select a student for an interview, what they are looking at is basically what kind of projects that a particular student has worked on, and how well has he worked on this project. Say, for example, here Praveen is designing a car hood, and how did he? What does emboss reinforcement mean? What does mastic data means? Right? What is section inertia analysis? And how do you go about it, right? And having this kind of understanding is what the industry looks for nowadays in order to develop and hire the right people. And this is only design, right? Say, if you're designing a roof of a particular car, how do you design that? What are the criterias? So you need to understand what is heat distortion, what is no load criteria, right? And how do you calculate that? Pen and paper calculations become very, very important, and applying those pen and paper calculations into your design and building that design becomes very, very important, right? So people in the industry, if you're in the quality or production, you're what you need to do is figure out which segment of design and development you want to do. That's number one, right? If you are inclined towards design career, then you probably need to look into what are the skill sets that you need to acquire as a design engineer, right? It can be sheet metal, plastic modeling. It can be in sheet metal, automotive body and white, or lights or surface design and seating design. So there can be a multitude, right? Once you do that, then your ability to have a portfolio kind of helps, right? Same. I spoke about design, right? One of the things that people also want to do is get into the CAE, computer aided engineering, which might be in the computational fluid dynamics domain, or it might also be in the finite element analysis domain. Again, the fundamental principle is, irrespective of you are a fresher or a 0 to 2 years experience, what the industry looks for right now is, have you had exposure towards the right engineering principles, right? How do you basically do that? How do you get that exposure? So usually people basically say, only if I get a job will I get that exposure. That is not true nowadays, right? With platforms like Skill-Lync, what you can do is you can essentially get this exposure. Say, for example, this is Abhiram's profile, and these are the projects that Abhiram has worked on. And when you think about this, right, when you have a portfolio like this, or like what Abhiram is having, this becomes your essential online resume. And what you can basically say, for example, here Abhiram is showcasing how he has performed a roof crash analysis on neon Dodge surrogate model. So, and this is essentially how an industry also thinks about engineering, right? And this is exactly when a engineer or an engineering manager who's hiring for a crash analyst or a structural analysis engineer, having understanding of, okay, this Abhiram knows the tool and also the fundamental principles that go behind the tool, becomes very, very important when you perform, when you apply for a job. So when you are looking to set up a career in design or development, think about what is the area that you want to get into, right? Here's a roof frontal crash analysis that Abhiram has worked upon, right? So see the amount of data and amount of a report that he has taken a look at. And how did he do that? He did not do it alone, right? Like here is where platforms like Skill-Lync help students, where they can work on industry oriented problems by learning those problems as a part of the coursework itself, right? So yeah, that and it was just one example, right? If you want to look into computational fluid dynamics, right? Again, this is Orge Lozano. Not only students across India, but across the world, they have understood that profiles, building profiles and working on industry oriented projects becomes very, very important, right? And that allows you to kind of, whenever you apply for jobs, help you succeed. So now saying that, I'll kind of stop my screen. And one of the things that I wanted to speak about was, if you are focusing on a particular domain, now your goal needs to be, in that domain, how do I gain that experience, right? If you're working on your production or quality or a non-core job, you can still get that experience. So you just need to figure out how to get that experience. So that's one of the questions. So I'm going to, there are a lot of questions, so I'm going to see those questions and answers. So Sarang, if you have seen a few questions that you would like to take up, you can do that as well. But
Sure, Surya. I'll just kind of, I was just looking at the first few questions. So I think this is from Dhananjay. The question is, I'm MTech fresher and CFD masters. How can one grow and be progressive in CFD domain? See, I think Dhananjay, if you're an existing student, I think you should try to connect with one of the recently graduated student called Neeladri. So Neeladri Bhushan was a professor. I think was an assistant professor or lecturer, one of those titles, and has been trying to move away from academia to industries. And from a progressive point of view, I think there's multiple ways to look at it. First is to essentially get into a relevant job opportunity, and for someone who is passionate about CFD, it could be a developer type of a role, or an applications engineer or a research engineer type of a role, or a CFD analyst type of a role. So essentially, in case of Neeladri, was able to get two opportunities, but the prominent one was essentially a CFD engineer at DRDO. which I think is very, very tough to get. So, great job on Neeladri's part. But essentially, those type of career transitions are very, very hard. I mean, if you've talked to other people coming from colleges, it's very hard to switch to industries, and be it research institutions, it's much harder. But then the idea is to essentially go to a place where your scope suddenly widens, Dhananjay. So if you're currently an MTech student and if you're taking our programs, I'm fairly certain that if you're able to write the codes that are shown in the course, you can actually use that to either get a job in an industry or a company. Another student is Gaurav Katyar, who essentially got into Convergent Science, which is a company that makes CFD software, right? And these are all roles where there's a really high quality of work that you can get, and that will essentially help you grow into CFD. I mean, if you're looking for progressive growth. So I hope that answers your question, Dhananjay.
Thank you so much, Sarang. Sarang, there was few questions with regards to computational fluid dynamics. I have heard you speak about this previously. Say, if you are a CFD, so if you are interested in computational fluid dynamics, irrespective if you're in a bachelor's, working, or a MTech degree, there are multiple solvers, so a 1D solver, a 2D solver, a 3D solver, right? And on top of that, you need a few fundamentals. And how do you, if I am a newbie and I want to become a computational fluid dynamics engineer, how should I go about it with respect to fundamentals, with respect to solvers as well?
A great question, Surya. Um, uh, so we get this question a lot. So the short answer is essentially, writing your own solver. At the end of the day, computational fluid dynamics, finite element analysis, or FEA or structural analysis, or multi-body dynamic analysis, the way they work is there is some type of a differential equation, most likely a partial differential equation, that is being solved by the computer. Now, these partial differential equations are essentially mathematical ways of defining conservation laws. So typically your conservation laws include mass conservation, momentum, energy conservation, right? Or any other scalars that have to be conserved. Now, these mathematical equations are, if they are solved for a fluid domain, then that problem is a computational fluid dynamics problem. If you take the same momentum equation and if you're solving it for a structural problem, if you're then that can essentially be considered as a multi-body dynamic analysis or a finite element analysis. So the first step is to essentially understand how you can go from this mathematic equation to a solution. So the first step that everyone needs to do if you're interested in this field is to essentially try to learn how to solve these differential equations using a programming language called MATLAB or Python. If you're doing that, you get an appreciation for what a differential equation is. You get an appreciation for what initial conditions and boundary conditions are. And then when you're solving it, you will be able to understand key terms like iterations, um, tolerance, and convergence issues, right? And as you dive deep, there are slightly additional concepts which are maybe for this audience might be a bit advanced at this point, which is called a stability, right? But once you have actually implemented all these things on your own, which is something most of our students do, what suddenly you get a full understanding of how differential equations and partial differential equations are solved. So this should be the first step. Once you have done this, you should essentially go and learn some type of a tool where you can actually do 3D analysis. Again, here the objective is to not learn the tool per se. The tool from a learning point of view really doesn't matter. If you're using ANSYS, if you're using Converge, or if you're using say Altair's product, it really doesn't matter. The idea is it essentially gives you a framework for solving 3D problems, right? And because when you're setting up those problems, you have to take you have to make multiple model choices, you have to provide multiple inputs, and you have to configure different solvers. However, if you have written your own code, that experience gives you a very good idea on how to proceed with a 3D package, and it really doesn't matter which software you're going to be using. Now, oftentimes in industries, 3D simulations are done when you want to look at something at a like very deep detail, because 3D simulations are very, very slow. But once the 3D simulations are done, right, what happens is people usually fall back to a simplified one-dimensional model, which is also called as a system level model, which is typically built in softwares like GT Power or Simulink, and then they basically run the models. These models are very very fast, but they are not very very accurate, correct? And the way the models are made accurate is by calibrating them, and the calibration is done based on the 3D simulations. So that is why if you learn the math correctly, if you're able to implement the math using some type of a programming language, suddenly 3D simulations, 1D simulations, or even 0D simulations start making a lot of sense. And you can also, with a fair amount of confidence, attempt problems in computational fluid dynamics, multi-body dynamics, and structural analysis. I hope that answers your question, Surya.
Thank you so much, Sarang. So guys, one of the things that I want you to kind of realize out here, and Sarang basically says this, is the if you want to develop a career in computational fluid dynamics, your fundamentals need to be very, very strong, right? And having a strong fundamental and then implementing that fundamental knowledge, the mathematics behind it and the physics behind it using a particular tool, that's where your 1D tool or a 2D tool or a 3D tool or essentially a solver comes into play, right? I want to highlight a few things. If you have a very, very strong fundamentals, there are strong career paths for computational fluid dynamics domains, right? So there was a candidate very recently, right? So this is Nikit Bowler, and he just messaged me this Wednesday. He's a existing student, and he just reached out to me. He's currently doing his masters in the US, and he just reached out and said, "Hey, I'm pleased to inform you that my Skill-Lync experience helped me get an internship opportunity at Alter as a CAE analysis intern. It's a $23 per hour, so essentially meaning 2.75 lakhs per month in Indian rupees, right? And if you basically take a look at Nikit's profile, what he did was he worked on strong fundamental projects in computational fluid dynamics. Right? For example, this is one of the things that he worked on as a Skill-Lync coursework is simulation of a 1D supersonic nozzle flow simulation. One of the reasons that you will take a look at here is he understands what are the governing equations are, right? What is the math behind it? And how this math is then taken into a solver like MATLAB. And he basically creates a code in MATLAB and takes out the results and kind of publishes that, right? This kind of knowledge allows him to take the fundamental knowledge then to probably a more 3D tool and take more deep dive on that, right? Say for example here he's kind of looking into the inside the engine, so with two different piston geometries, right? And he's basically looking into pressure variation and temperature variation in the cylinder, and all these kind of projects essentially help you get that engineering experience that I was speaking about earlier, right? Here's so he's basically looking into how combustion acts and the temperature variation during the combustion process. That essentially helps individuals to kind of get that engineering experience. And when you start interviewing, these are the questions that they are going to ask you, right? This is another student who Tilak, right? Sarang was speaking about the 1D tool. Here, he basically performs a turbocharger analysis, and you can take a look at how he has set up the whole 1D simulation, system level modeling, what they call, with GT power. Again, the tool becomes tool when you start interviewing. One of the things is tool is probably 40 percentage. The fundamental is 60 percentage. You need both, right? Say for example, you can have 40 percentage of the fundamental and 20 percentage of the tool. You will get selected, right? You but with 60 percentage fundamental knowledge you might get selected, but just the 40 percentage tool knowledge you might not get selected. So it's a combination of both, and you need to, when you start building your career, you need to start thinking about it in a fundamental way, right? So that's something that I wanted to kind of speak about. Let me kind of see if there are any other questions. Okay, so Ranjita Sudha Gowda. I'm going from the down, and the question is: I'm finally a mechanical student, and I want to do design. So, what are the best softwares I have to learn to get the job? What are the areas are there in the industries which is best for girls? What are the job opportunity for girls in design? Irrespective of girls or boys, the opportunities in design are a lot, right? So, let me kind of try to dive it a little deeper, right? So if you basically take a look at design, there are few aspects of it. Sarang, can you see my screen?
So we're seeing
Word
a
document.
Word document, yeah.
Yeah, yeah, great. Right. So if you're basically looking into design engineering, right? So especially if you're looking into the whole design engineering domain, what we would basically categorize is there is product development and there is manufacturing design. So you can also kind of take this as product design and this is manufacturing design, right? If you look into product design, you will look into solid modeling, surface modeling, sheet metal, and plastics. If I basically look into design, there are solid models, surface models, sheet metal, and plastics. Now, if I basically go one step further, which is essentially what are the different domains available? Like, so there are automotive design, oil and gas, right? Then there is your rail domain. Then there is your aerospace. I think there is medical as well. These are probably I would say top. Then there is power. So these are probably 5 or 6 domains. There might be additional, but I'm basically taking a look into the top 5 or 6, right? So you can basically learn all these 4 with respect to one of these applications, right? So you can learn solid modeling, surface, sheet metal, plastics for automotive or for oil and gas, for a rail domain or aerospace or medical or power. And how do you do that? Say, for example, if you take a automotive car, right? So there is something called BAW. So BAW is nothing but body in white. If you do not know what body in white is, it's the what should I say, skeleton of the car, right? Body in the components that are assembled to the car before painting is called body in white. So usually these are sheet metal and a little bit of surface modeling. Sheet metal and surface modeling, right? Will kind of come here. And if you basically look into, then probably you have your lighting system, which is a little bit of surface. Then your seating system includes solid and sheet metal and wiring harness. So here is where it's about electrical components, right? Lighting, seating, BAW. If you want to be design engineer, like then probably what they call it as surface design. So probably with tools like Alias and whatnot. So essentially, you have these different applications under automotive, which allows you to focus on sheet metal, surface, solid, electrical components, and also surface design, right? Like this allows you, so this is essentially sketching and class A surfacing, right? There might be a few aspects that I might be missing out, but what I wanted to explain out here is if you are basically taking an automotive domain and learning these skills, your ability to kind of apply this to any of these domains will be easier. Now, in addition to this, you need to also understand probably solid mechanics and design of machine elements. So your fundamentals need to be good, right? Once you have this good fundamentals and once you basically have all these in one particular domain, your ability to kind of jump into multiple other domains becomes easier. Now, Ranjita, coming back to your specific question, as a design engineer, your ability to get into these jobs will be very, very high if you have these skills. And not only for Ranjita, right? This is true for all the other engineers as well, right? So if you are looking into manufacturing design, then there is mold design, tooling design, and the other aspect that is available is fixture design, right? So these are a few areas where you can basically focus on as well. So if you want to focus on a design engineering career, these are the aspects that you have your options on, right? All these are individual. Say for example, if you basically take, this is an individual engineer's role. So if you basically see here in automotive alone, there is 5 engineering sections, and and in manufacturing there's 3. So 5 3s are 8. Then probably you have 6 application areas. So 8 into 6, 48 to 50 job roles are easily available as a design engineer. Like, I'm just uh, trying to give you a sense of the roles that are available, right? So these are the different types of roles that are available in the design engineering aspect, and you can take a look at it if you are applying for design engineering roles. The only thing that you need to understand is you need to have a very, very strong understanding of fundamental design in order to succeed in these areas, right? Great. I'll kind of look into other questions as well. Blender 3D, what are the advantages in procurement? What are the opportunities, CFD domain? Sarang, do you want to go?
Yeah, so I've actually, guys, for some of your questions, I've just privately pinged because it was very, the situation was very unique. But I'll just kind of, in case others are also interested, I'll just go give a quick overview of all those questions. See, the first question was, there was, if you're in production engineering and if you have spent more than 8 years, how do you switch? Given that you have so much experience in that field, generally it becomes harder to switch, primarily because from a company's point of view they might think, hey, why is this guy switching to a new role? There is a lot of questions that gets asked, but then at the end of the day it's a numbers game, right? All you need is just one opportunity, right? So in that situation, what you need to think is you need to first upskill yourself in the area that you want to move. So given that you've already spent 8 years in one career, I think the next one, make sure that you're picking an area where you think you will definitely do well. And upskilling is definitely required because you have to start showcasing projects. But then, while doing so, retain your old job, upskill well, work on good projects, and start looking in the side. Blender is not used for any type of engineering type analysis or design, because you need a fair amount of accuracy, especially because these parts eventually going to get manufactured, right? What are the advantages of being? This was a very Karthik. The question was not well put, but the short answer is I don't think there's a specific advantage of being in procurement and doing material engineering versus being a production engineer. At the end of the day, you want to essentially be in a role that you really like, and you want to essentially work in a company where you're getting challenging projects. There was one question regarding CFD opportunities for bachelor student. See, generally the opportunities for bachelor students tend to be more on the pre-processing side, which is meshing. However, there are jobs even for bachelor student where they can essentially take up the role of setting up the simulations from end to end. These opportunities are a bit rare, but for example, there was one Skill-Lync student called Shikar Saraswat. Yes, he was very, he really wanted to get into a research engineer type of a role where he has to research about the problem statement, set up the problem, simulate it, and also optimize it, because obviously that type of work is of high quality. He essentially waited and kept applying for all relevant opportunities, and in I think his job search process overall was say 6 to 7 months. And if you're a BE student who is going to try for that type of position, please remember that the interview is going to be very, very hard, because for end-to-end simulation ownership, that you need to be good in math, you need to be good in scripting, programming, and also the software tool. All of that gets tested, and Shikar through his project was able to demonstrate his competency across all these key points, and he was able to get a job.
And one of the questions that I basically saw was with respect to, I think it was Syed Sain Uzair, which Sir, last year I was interested in CFD, and this year I'm interested in NVH. I'm confused which one to choose, and also I'm confused between automotive and aerospace engineering. I like both of them. Which will be better for me? I'm in sixth semester of mechanical engineering. What would your recommendations be, Sarang? Say that is a lot. This is something very common, right? Like one time you are interested in CFD, the next year you're interested in say FEA. How do you go about it?
Yeah, so I'd ping this person. So I think the short answer is, see, at the end of the day, like NVH, CFD, FA, or MBD, right? You might find it interesting because at the end of the day, these are all simulations, right? You're trying to predict how a system is going to behave. Maybe that is your core interest. If that is your core interest, and or it could also be, looking at the results in a 3D environment and looking at your simulation in real time. I think that is where you're getting the satisfaction. So in that case, I think you should first spend time learning about the core mathematics, because then you will be able to understand how these simulations work. And then automatically, when you educate yourself in that, you will automatically see that there are certain areas which are more challenging than others because of the complexities, and that can essentially help you focus into one domain. An example would be, if you take simulating structures versus simulating fluids, right? Fluid flow simulations tend to become more complex when the geometry is very, very complex. But for a structural analysis, what you can do is you can get away from the complexities by essentially removing parts of the geometry that are not required. But in fluid flow, right, making such changes becomes hard. And also the way the equations are solved and the type of solvers that you use for the type of flows changes a lot as well. So that complexity, for example, was interesting for me when I initially wanted to take up CFD, right? But that understanding would come only when you understand how these tools or how these different areas function from a fundamental viewpoint.
And one of the questions which came in now was, how do we connect CFD and CAE? Is learning both useful?
I think yes. See, for example, you need to understand that CAE stands for Computer Aided Engineering, and CFD is a subset, meaning CAE essentially covers pretty much everything, right? And the way to think about that, Ajit Kumar, is, there are certain problems where both CAE and CFD is used. I'll give a very simple example. Think of your gas turbine engines or aircraft engines. What's going to happen is, as you have air interacting with these blades, you have combustion taking place, and you have the exhaust products interacting with these materials as well, right? Now, in this case, there is CFD. There's clear turbulent reacting flow, essentially flow that's combusting. That's what you call as turbulent reacting flows. And then this flow is also interacting with the fluid, interacting with the structure. So there is fluid structure interaction. Because of this interaction, there is going to be dynamic loads or periodic loads acting on the vanes, and this fluid load now suddenly becomes a boundary condition for your structural analysis. So this is a single problem where CFD and FEA are related, right? Now, obviously, you can take this even more further. If you essentially want to get the fluid induced noise, you can essentially put a small virtual sensor in your fluid field. Again, I'm talking about computationally, and you can measure the local pressure variation. And once the pressure variation is obtained, you can do a lot of things, like what type of frequencies exist, what type of pressure waves are produced, and if these pressure waves can uh, further deteriorate the performance of the structure. You can ask questions like this, and this would be called as a coupled analysis or a multi-physics simulation, because you are simulating multiple aspects of the physics in this particular problem. There was another question. I think there is Akash, just like Akash, there was another guy who asked this question. Hey, I've completed my master's, say, outside India, and I want to come back. I think the country that they had mentioned was Germany. If you're coming back, are there good opportunities? Like I said, absolutely yes. It's not like there are in India. The problem is not lack of job opportunity; it's the lack of talent, right? Um, so essentially, if you're skilled in the right area, and if whatever you've studied is useful for that particular company. In fact, I would even be very confident in saying that your profile would be given a higher preference, especially for OEMs that can afford paying a bit more, right? So I think
Yeah,
Akash, I
yeah,
hope that answers your question.
great. So one of the I'm going to combine a few questions which were in CAE. The questions kind of were of the nature: what is the scope in CAE? How to improve as a CAE engineer if I'm in the undergrad? If I do not have experience in CAE, or if I'm joining my company, how do I improve? And or what to go about it, right? Sarang, oh, so let me. I'm going to assume that when they speak about CAE, it's essentially structural analysis, right? So can you break down what are the aspects of structural analysis, pre-process, solver, post-processor, and if you can give us an idea of what a company expects from a fresher who is joining as a structural analysis engineer, and say an experienced professional, a 2 year experienced professional, and how can a fresher get 2 years even without getting into a job?
Sure. See, guys, I'll give a very simple example, and maybe this can be a very short lesson on FA also. See, think of really large concrete mixtures that you see on the road. These concrete mixtures would essentially pour concrete for flyover projects and bridges project, right? These are things that you guys would have seen, correct? Now, obviously, when designing such a large structure, the key element which would cause failure is the weight, the self weight of the component, right? Because these trucks weigh several tons, so the self weight is going to be the problem. And essentially, what happens is your truck is at the end of the day made up of some type of a material, and this material is being loaded, which in this case, the type of load is just self weight. Now, every material has its own strength, correct? In some ways, the strength of the material can be quantified by looking at the Young's modulus or the ultimate strength, right? So this is where you need to first understand, okay, for my material, there is a stress and strain relationship. Now, if you want your component to be loaded and then the load is removed, the component has to come back. And if this component is a mission critical component, for example, a mission critical component is something that you would say use in a nuclear reactor, right? You would try to over design it as much as possible. Essentially, when I say over design, the factor of safety would be very, very high. Whereas a non-mission critical component which is designed would be your plastic Neil Kamal chairs, right? They are plastic components. There's a plastic designer who designs this. For example, if you sit on it over time, you will see that it stops to come back to its original shape, meaning it's being loaded outside its elastic limit. But then that's okay till it doesn't break. We would have those chairs, right? So essentially, the idea is if I know the material and if I know my load, I will be able to see if the material can withstand it and if it's going to be in the elastic range, meaning is it going to come back to its original shape or will there be small yielding that takes place. Once I've understood this, then what I need to do is I need to be able to take this model and then I need to be able to simulate it. And to simulate it, the first question that we ask is, okay, what are the governing equations that we need to solve? If the material is like in case of the concrete mixture, what I'm do concrete mixture trucks, we know that it's static loading, meaning the truck is not moving anywhere. We just assume that it is carrying this much amount of load, and we are going to be looking at see how the chassis is going to withstand the load. So in this case, the boundary condition is very simple. I want the full geometry to be modeled. I know that the weight is a key part, so I need to make sure that the model essentially weighs the same as my actual truck. So once I'm able to get my boundary conditions, I need to know again a small thing that I missed before. This is the governing equation. Since it's a static problem, the governing equation becomes F equal to Kx. So here the interviewer would ask, what is the stiffness matrix? Right here, explaining that the stiffness matrix relationship provides a relationship between the provided forces and the displacement at any given point of the truck. That is very, very important. And also being able to say that the stiffness matrix, the global stiffness matrix, is essentially an assemblage of local stiffness matrices. And then essentially the local stiffness matrix is element dependent. So depending on the type of element you have, the stiffness changes, right? And that is why for those of you who know a little bit of meshing, if you use a tri element versus a quad element, the stiffness changes. Why does the stiffness change? Well, at an element level, you are modifying the relationship between force and displacement. So when you're doing at an element level, an entire part is nothing is made up of multiple elements. So the part's stiffness is going to get is going to get modified. And at the end of the day, a truck is made up of multiple parts. So you can essentially extend the analogy. If you have this level of clarity on how essentially F equal to Kx plays a major role, how the element selection is important, I'm fairly sure that you would clear most of the interviews. Now, coming back, instead of a concrete mixture, if the application is slightly different, and it can be a very simple problem, right? Imagine that there's a pipe that's carrying water, and the pipe is being heated externally through an electric heater. Here, being able to say that, okay, inside I have to do a fluid analysis, and outside I have to, and in the thickness of the pipe, I have to do a heat transfer analysis. And then the heat flux is my boundary condition, and the unit of heat flux is watt per meter square. This notice that I've not talked about software, I've not talked about hypermesh, ANSYS, or any of those tools. Being able to answer this takes you a long way, but the funny thing is, in order for you to get the interviews, the project is important. So the project essentially helps you get your foot through the door, but in order for you to clear the interview, you need to be very good in fundamentals, right? I hope that essentially answers your question, Surya.
Yeah, very helpful, Sarang. So, guys, now I just wanted to kind of take a segue, right? Like a lot of you are asking in the comments, how do we get these skills? Surya and Sarang, you're giving, with respect to giving ideas of how to clear interviews, but how do we get these skills, right? So, here's where I wanted to kind of showcase a few things. Sarang, can you see my screen?
Yeah, yes, Surya.
Do you see the CAE Master
CA
Certification
Masters
Program?
here, yeah.
Great. Guys, so if in the CAE Master Certification Program, these are the 10 courses that, so this is a year-long program, right? These are the 10 courses that we essentially look at. Hypermesh for FEA plastics and sheet metal. So taking one step, so after you clear the interview, there are three roles, like pre-processor, solver, and post-processor. So if you are a fresher or a 0 to 2 years experienced candidate, you are going to look into pre-processing, which is essentially meshing, right? So understanding how to perform meshing for sheet metal and plastic components becomes very important in the automotive and any other sector currently in the industry, right? So hypermesh and ANSYS are the two tools that industry uses a lot, right? So this is where we start the coursework, and this is where we also speak about a few fundamentals that Sarang spoke as a part of the fundamentals that, for say, it can be stiffness matrix and whatnot. So all those fundamentals will be starting over here itself. Then the third coursework is automating meshing. So if you basically know about meshing is a process where it is tedious and you can automate meshing. So here you learn TCL TK. So if you are in the 2 to 4 years experience, if you want to kind of get a better role, automating meshing becomes very important. Then so once we kind of the first three courses, the first 30% of the coursework focuses on pre-processing. The next 80% of the coursework, which is essentially course 4, 5, 6, 7, and 8, focuses on solver. So you look into LS Dyna for structural mechanics, finite element analysis. So you understand the fundamentals of finite element analysis using LS Dyna. Then you look into crashworthiness analysis using hypermesh and radius. Here you look into automotive domain crashworthiness analysis. Then you look into FEA of aircraft primary structure using NASTRAN and PACTRAN. Again, aircraft cabin interior monuments, stress analysis, and FE modeling in MSc pattern. And introduction to structural analysis in ANSYS workbench. These 5 solvers allow you to understand how solvers work and also the fundamentals behind finite element analysis, right? Then the last 2 courses focus on pre-processing and automation. So you look into automation and structural design using MATLAB and Master, and introduction to automation using ANSYS Workbench and Python. This is one of the coursework that Skill-Lync provides for students in order to succeed in a CAE/FEA career. This coursework not only caters for students who are currently studying, but also caters for anyone in the 0 to 6 years of work experience. So essentially, if you want to get into the CAE domain, this course focuses on that. Similarly, Sarang also spoke about the computational fluid dynamics pro. So CFD, again, CFD like FEA has pre-process solver and post-processor. I will kind of ask Sarang to explain these 10 courses and how it is structured a little bit.
Sure. So guys, here, like I said, the first course essentially focuses on the math part of CFD, and then what we basically did was we introduced people to a tool called OpenForm, and then based on user feedback that the OpenForm part was, it started and there are not a lot of projects. We put in a new course called Introduction to OpenForm Development. So this is where you are now suddenly able to compare how when you write the solver, what is the level of complexity that you handle versus how a professionally written solver takes care of it. So this is very very important because it furthers your understanding even more into OpenForm. Now, the third course, once you have done this, hopefully you are at a point where you understand what equations are being solved and how are they being solved. So now you get into a slightly more professional package, which is ANSYS Fluent. So here, first is you get your hands dirty by running a large number of simulations, different physics. So here the focus is more towards the software part. It's going to be less theory heavy. The first two courses are more theory heavy. The third course is less theory heavy. So what I have sometimes seen is if a student directly comes to course number 3, you would feel like there's a lot of gaps in the theory. However, the right way to take this is you have to always take the first course and then the third course. And then once you have learned a little bit of ANSYS Fluent, we kind of dive deep into slightly more complex simulations where the need for setting up the physics a bit more carefully is very high, because these simulations are very very sensitive. So you do a lot of external flow analysis at very high Mach numbers in that particular course. And then in course number 5, 6 and 7, the idea is to essentially jump into more complexity with respect to the simulations. So here, hopefully at this point, you understand CFD very well. You understand what are the equations. You understand things like turbulence modeling, transport equations, transient solver, implicit, explicit, all that stuff. So now you're purely focusing on looking at the engineering data that you get from the simulations. That's what 5, 6, 7 are. And then 8 is essentially going to give you a glimpse of 1D. And I'm telling you that this experience is extremely valuable. Courses 8 and 9 will essentially help 3D engineers learn 1D simulations as well. And this essentially broadens your perspective. You are looking at just, in courses 5, 6, in fact, courses from 3 to 7, right? You have been focusing purely on just a component. It could be a turbocharger or a compressor or an IC engine. In courses 8 and 9, you're looking at an entire vehicle, right? And you will see that the entire vehicular model is way fast and it is way more useful in terms of getting high level engineering data. And that perspective essentially is very, very helpful because over time, as you grow in this career, if you essentially get into a company, right, at a very high level, for example, say you are going to be the director of the simulation program, the expectation is you should have experience in multiple simulation methodologies so that you can recommend what's the right type of simulation pipeline for your organization and the products that you are responsible for. The course number 10 is primarily intended for pre-processing. See, this again goes with my previous explanation, right? For bachelors, the job tends to be more on pre-processing. So that could be, and if you look at the industry, it's either done using ANSA or it's either done using ANSYS. And these are the primary, again, Converge is also being used, but primarily for a meshing point of view, it's either ANSYS Fluent or ANSA. The reason for covering this is, at the end of the day, if you're a B student and if you're looking for a job opportunity, you can definitely get a job opportunity in meshing based on these two tools. These just courses number 3 and 10. However, just taking those courses alone might not be helpful because you still need to understand what's the basics of CFD. So anyway, courses number 1 and 2, 1, 2 and 3 are almost like a must take for anyone who wants to get into the CFD domain. I hope that makes sense, Surya.
Yes, Sarang, thank you so much. As Sarang described the CFD, and I also wanted to take you through the design program, right? And this design program, I spoke about it previously about what are the pathways available, right? So at Skilling we provide two pathways. One is the sketching specialization, and the second one is the manufacturing specialization. Very small difference. I will explain what the difference is. So in the sketching specialization, you start with automotive sketching. This is where you understand how to do hand sketching. Then you look into use a alias to focus on class A surfacing. So if you are someone who want to get into product design and development, right, which is in the ideation phase, then probably these two courses will help you a lot. The Ultimate SolidWorks course and SolidWorks Boeing 74 design. So this is a pure solid modeling coursework. So here you design a Harley Davidson bike, a Boeing 747, and a yacht. And the whole thought process is to make sure you are very versatile in solid modeling, surface modeling. So by the end of course 3 and 4, you know everything about solid modeling and surface modeling. Then comes the important aspect of it. So we take a particular application, right, and basically focus on automotive sheet metal design, which is the body in white design, automotive seating design, plastic design. These are the plastic components that you look into in an automotive car, your trims and so on. Automotive lighting design and wiring harnesses. These five courses are very, very important because it provides you an overview of sheet metal design and solid modeling and surface modeling for a particular application. So irrespective of if you're going into the automotive domain or not, you basically focus on these five courses because all you need to do is just understand about the newer domain that you are going to get into and apply the same fundamental principles. Then you look into gap and flushness in automotive body design. So this is the sketching specialization. With respect to manufacturing specialization, what we do is essentially we remove these two courses and substitute those two courses with respect to mold design and BAW fixture design. So if you remember in the Word document that I basically typed, so I spoke about mold design and automotive BAW fixture design in the manufacturing specialization, and this is essentially helpful there, right? Um, so the other thing that I also wanted to speak about was with your experience as a production or quality engineer will always be helpful for you to switch into a design or a CAE analysis because your ability to read drawings is much appreciated by companies, right? So this is something that I would kind of mention as well. Then I also wanted to show you one of the courses, one of our hallmark courses, which is our master's program in hybrid electric vehicle design and analysis. So with a lot of electrification happening across India and around the world, what we have come up with is a coursework on hybrid electric vehicles. It's a 2 semester year-long program. All these courses are year-long programs where in the first five semester you look into the introduction to MATLAB and Simulink, then introduction to hybrid electric vehicle, its architecture, controls, battery technology, and ADAS, automated driver assisted system. In semester 2, you have two compulsory courses. Then you can basically pick a particular track and specialize in that track. You can pick a computational fluid dynamics track, FEA track, and computational design track, or even a multi-body dynamics track, and essentially specialize in that. So if you basically take a step back and remember Sarang's first point, your ability to get into an electric or a hybrid electric vehicle industry depends upon how, as a mechanical engineer, depends upon how good you are able to interact with the electrification aspect of the company for the role that you're focusing on. As a CFD engineer, how can you perform battery thermal simulations? As a FEA engineer, how can you understand the electrification related structural analysis that you need to take into account? As a computational design engineer, what are the electrification aspects that you are taking into account? Same for this multi-body dynamics or the suspension design or the steering kinematics or vehicle dynamics engineer. So these are courses that we are bringing in, and these are some of our hallmark courses. We have essentially using these courses, we have placed almost around 500 students over the last 1.5 to 2 years, and we have had great success. So if you're someone who is looking to build a career in these domains, so definitely take a look at it. There is something we are, while there is a price, since we have added new courses, there is a price hike, but we have also providing a special offer for till 31st. I think there are around 20 seats that have been added, so do take a look at it if you are interested. So just wanted to give an overview about this as well. I'll stop my screen and see if there are any additional questions. Sarang, if you have any questions that you want to answer, would love to kind of
Um, so, okay, one second.
I'm just seeing the comments as well. So
Yeah. So Jayesh, is what is the future of CFD, and will it be able to survive an era of EV as major portion of CFD analysis is used in ICE? So Jayesh, the first part is not correct, right? See, at the end of the day, CFD is primarily for flow analysis. So as long as you have, if you have fluids flowing around in engineering systems, you will always end up having CFD. So battery is a great place. If you have power converters which essentially emit a lot of heat, so the enclosures that have to be designed, if you want to look at the airflow, CFD is used. Your good old HVAC systems, which essentially is your air conditioning inside your car, that is not going to go away, right? So when people say that there is a dual zone climate control, how do you ensure that there are two separate thermal zones within a car? All of that can be simulated in CFD, fairly straightforward, and very, you can do it in a very accurate fashion as well. Again, see, don't think in terms of, I understand why you're asking this. The question is CFD better or FEA better? I think uh, if you're thinking in terms of more career, if you want to get an entry level job, the smartest thing to do is essentially learn both. Like I said, at the end of the day, they involve solving set of differential equations. In FEA, the differential equation is F equal to kx, or it's Newton's second law, right? Mass times acceleration plus damping matrix times velocity plus k times x equal to the external force. That is nothing but F equal to ma, and F equal to ma written for fluids is nothing but the Navier-Stokes equations. At the end of the day, you have partial differential equations in both the cases. The geometry is different. The numerical method used is different. In structural analysis, it's typically FEA, whereas here it's FEM, finite volume method. That's it. So, Jayesh, if you're really confused and if you're not able to pick, it's perfectly fine to pick both and have two versions of your resume. And this is one of the things that we constantly help our students with, right? We make them have two versions of resume, where one version is just a CA. For example, if Jayesh, if you are, I don't know if you're a student of Skill-Lync, but if you are, then you will have Jayesh underscore CFD, which would be your CFD resume, and Jayesh underscore FEA, which would be your FEA resume. And depending on the opportunity, you can essentially, apply with the right resume, prepare accordingly. And as Surya said, the focus is the tool knowledge and the projects help you get the interview opportunity. But to clear the interviews, it's 60% weightage is given to your fundamentals. And in fact, I would even say it is 70 to 80%. And then the remaining, whatever it is essentially the projects that you have done.
great. Thanks, Sarang. So yeah, I had in HEV for the second semester, the specialization courses are limited with separate masters. And why is it? It's just the time duration, Ajit. So we have picked on a few courses that we believe will provide the essential mix. In case you want to add additional courses, so you can essentially request and we can add it up. So that's without additional fee. For our HEV course, we basically do that, right? So I think this is I know some of you had asked a question with respect to software required. Veerabhadra, you had asked with respect to for what are the software required for mechanical engineering? What software should be learned by mechanical engineers? Uh, Veerabhadra, I'll kind of take you to the Word document that I spoke about, right? What is more essential is understanding, does Veerabhadra know solid modeling, surface modeling, sheet metal, plastic, or any of these one well? And can Veerabhadra take this and apply it to a particular domain? So that by itself will get you a good job, right? Now, softwares are important, right? When I spoke about 60% theory, 40% tool, say for example you're taking up NXCAD and understanding or CATIA and doing everything in CATIA, your ability to switch from CATIA to Creo or CATIA to SolidWorks or CATIA to NXCAD will be very easy. So it will take time, it will take 2 to 3 weeks, but it is not a lot of time, right? So the ability to think about, okay, what is hemming, what is, how do I design a particular bracket, what are the different tools available. So if you understand that particular aspect of the tool, you can essentially search for the same options in another tool as well. So it is like using a Mac and a Windows. So if you basically know, in Windows there is a Windows bar, there is so there are a few keys that you can basically click to do certain stuff. You can figure out what's the same equivalent for a Mac. Very similar. A tool is essentially has the same opportunities and the abilities as all the other tools. It's just that you need to figure it out, right? So softwares are not important, but if you want me to kind of rate, I would rate CATIA, NXCAD 1 and 2, SolidWorks 3, Creo 4, right? And essentially you need to have an understanding of sheet metal, plastics, surface and solids in all of these, right? So if you know one, it should be good. So a lot of you had asked, I want work experience. So I've finished my bachelor's. Should I enter into an MTech degree? Because the jobs that I search for looks for work experience. Guys, the only way that you can get work experience is working on projects. An MTech degree only adds a degree to you and not a work experience, right? The only way you can get work experience is by working on engineering projects. So that's one of the main reasons why we focus on engineering projects, right? Pratik Rawal, I have attended the last Q&A in which I got some idea of building a career as a freelancer in CAE, but I would like to get more idea how I can start freelancer as a hybrid and electric vehicle. Pratik, if you, since that's a very broad question, I don't know if you want ideas for a freelancing or what are the fundamentals needed for freelancing. If you are asking what are the fundamentals needed for freelancing, what I explained before kind of is the same answer, right? Raghav, sir, do you mean to go work in company mechanical job, right? No, Raghav, I'm basically saying work on projects, right? You don't necessarily need to work in a company to work on projects, right? So let me kind of explain what I mean by that, right? So for example, every Skill-Lync student essentially has a profile, right? So this is, we share this URL with all the companies that we partner with, right? So essentially, if you basically look at any of our students out here, they would have worked on projects. So let me click on Aravind Gunashekharen. I'm just randomly clicking. I'm going to design and I'm going to click on a few design Sonu Raj, right? So if I basically look at Sonu Raj, I'll basically take a look at, okay, what has Sonu Raj focused on, right? And what are all the projects that he has worked upon. Once I understand the projects that he has worked upon, I can basically click on it and take a look at it as well, right? So core and cavity design. So I'm going to click on it and see, say for example, this is a core and cavity design. And if he is basically applying for a manufacturing design kind of job, I'll basically look at, okay, what has Sonaraj worked on? What is the kind of project? Does he know about core and cavity? Does he know about tooling access creation? Right? What is draft analysis? Has he done a draft analysis? And as a production manager, these are the questions that I am going to ask in an interview, right? And if Sonaraj answers these questions, so if I basically see this project, I will call Sonaraj for an interview. Then he needs to have a fundamental understanding of what he has basically worked on in the projects, and he needs to explain his project in a very solid way, right? And that's the same with Arvind Ashwin, right? He has worked on multiple projects. Say, for example, if I want to pick a particular project and take a look at it, so centrifugal pump design analysis. So I'm looking for a CFD role. And if I am able to understand what kind of analysis that student has worked on, this allows me to see, okay, the student understands the fundamentals of computational fluid dynamics and I set up a simulation as well. Now, this allows me to call him for an interview and ask fundamental theoretical questions. And then if he clears that, go for a tool test. So when I basically speak about having engineering experience, I speak about having work experience on working on engineering projects, right? And that's essentially all these students have worked on. And you can basically go to placements, skilling.com/placements, and you will basically take a look at all the students. And these are students who did not have experience in the domain of their interest, right? And these are people who got recruited based on the projects that they have worked upon, right? And this is essentially, and you can just click on it and take a look at it. I'll also paste this across in the chat box so that you can take a look at it. You can essentially take a look at these placements as well. So yeah, just wanted to speak about that. Raghav, yes. So students who enroll in skilling coursework essentially can work on those projects. Yes. Great. Okay. I see a lot of questions, but since on the matter of time, I'm going
So
to.
one second, Surya. So Pavan Kumar, questions regarding good universities. Please check your private message. Essentially, you should check out the blogs that we have. And Manoj, your question has also been answered. I've sent a PM for you.
So just to kind of look into our blogs, it's skilling.com/blogs. You can also take a look into the universities that you can apply for based on that. There are a lot of good blogs that we have written with respect to how, and it has been categorized as well. So you can basically look at it as well. So here's the link for that as well. Right? Super. So just wanted to kind of speak about a few additional things. As I said, we have the courses that I showed, the CAE Masters, Design Masters, CFD Masters, are all revamped courses. So previously we had 6 courses in a master's program. Right now we are adding 4 additional courses, and even with our hybrid electric vehicle and electric vehicle program, we are partnering with MathWorks and delivering a 1 month long live training session on strong EV and HEV concepts, right? So if you are someone who is looking forward to enroll in a coursework, what we have done is essentially over the next 2 days, you can enroll in our coursework. These are the courses that we have. So the masters in hybrid electric vehicle, design engineers masters, CFD engineers masters, CAE engineers. Since the crowd is a lot of mechanical engineers, do take a look at this. As Sarang also put in. So in this year alone, from Jan to now, we have basically placed 100 students, and that number is going up, right? So the basic program has been revised from 2,50,000 from its existing 1,50,000. Pro 3 lakh to from 2 lakh, 3 lakh 50 from 2 lakh 50, right? So what you can do is essentially enroll in the course, revised coursework at the existing price and not the revised pricing, and also get a 3 month paid internship as after you finish the coursework. It's a 10,000 rupees per month paid internship where you will be working with an industry expert on industry oriented projects. So if you are interested, do put in your name, email ID, and phone number. We'll basically get in touch with you. This link is also shared with you. I also saw a lot of students who already enrolled during this webinar. So that is essentially, we do provide 12-month EMI options. So you can basically pay the course fee in 12 equal installments as well. So if you are interested in the in knowing more and want one of our technical experts to schedule a call with you, you can basically reach out to us as well, and we can provide you. Pawan, you joined Skill-Lync last year. Now, am I able to have those new extra 4 courses? Since you are an existing student, yes, Pawan, you can. Suresh, thank you, Suresh, for pre-booking the CAE Masters course. Thank you, Vivek, for pre-booking. Guys, if you are interested, do let us know your name, email ID, and phone number, and we'll basically get in touch with you and provide you more information. Or you can basically just say your name, email ID, and phone number on a private message. I have received around 8 private messages right now. I'll get in touch with you guys. If you do not have any questions, Sarang, thank you so much for joining. You can exit the meeting. Hope this was helpful for a lot of you. And thank you, Sarang, for taking your time and
Yep.
coming here.
Sure. Thanks, Surya. Thanks for the opportunity. And guys, really wonderful talking to all of you. Hope you found this session useful. See you guys soon. Bye.
Thank you. Shakib, if you can also in a private message send me your email ID, that would be helpful. Abhinav, if you can put your name, email ID, and phone phone number, that would be helpful. Thanks, Rohit. Guys, if you are the meeting has ended, the AMA is ended. So if you are someone who wants to enroll, you can wait and ask questions. Looking to enroll right now, you can leave the meeting. Thank you so much for joining us on a Sunday evening. We really appreciate your enthusiasm. Hope this was very helpful for you. And if you are interested in knowing more about our courses, put your name, email ID, and phone number. We'll reach out to you immediately over the next couple hours. Sunil Kumar, what are the subjects we can get familiar to get a job in design field? Sunil, I think I answered this in the AMA. If you are asking the theoretical subjects, definitely strength of materials and design of machine elements, and then good fundamentals in plastics, sheet metal, and surface and solid model. Hope you had a good session. Thank you again for joining. If you are interested, do let us know your name, email ID, and phone number. We'll reach out to you. Super. Thank you, guys. See ya. Bye.